Okay, sorry, I forgot to record. Okay, later on I'll just give you this PDF file. Okay. So for B, what is the probability that the car requires a tune-up but not a brake job? Okay. So require a tune-up but not a brake job. So meaning that, how to write it? Require a tune-up but not a brake job. B complement, right? Okay. So it's like this, huh? PA intersect B complement. Okay. If you want to draw a Venn diagram, AB. So probability of this whole A here is 0.6. Probability of B here is 0.1. And the intersection here in the middle is 0.02. Okay, so probability of A intersect B complement. Where is it? It's by A intersect B complement. So this is your B. This is your B here. Other than B is B complement. And you just want to intersect with A. So just this region here. You see on screen? Well, the screen is a bit lagging, eh? Okay, can you follow? Can you follow? Yes, this is B. Okay, other than B is B complement. And we just want to intersect with this A here, this part here. Okay, so the one in yellow part. So the whole thing is 0.6 minus the intersection part here minus 0.02. So the answer is 0.58. Okay. For part C, what is the probability that a car required neither types of repair? Okay, neither types of repair, meaning that you don't want tune-up, you also don't want brake job. Okay, so this is the way to write it. Probability of A union B complement. Okay, probability of A union B complement. Right? So it's just, we already have the answer, right? For A, we already have the answer for A union B just now, 0.68. So just take 1 minus probability of, just take 1 minus probability of A union B. Okay, so the answer is 0.32. And lastly, the question asks, is it independent? What's the meaning of independent? Let me do a revision here for you. The meaning of independent, meaning that PA, the meaning of independent, meaning that PA union B is equal to PA times PB. You remember this formula? You remember this formula? Okay. It's from this chapter. The meaning of independent is PA intersect B is PA times PB. All right. This is the first method to check if it is independent or not. The second one is if it is conditional, it is just PA. Okay, because we are not depending on the second event back here. Right? So doesn't matter if you use PA Actually, it's the same one, okay? For example, P star given triangle. This is just probability of star. Okay, because it doesn't depend on the first event back here. Okay, that's the way to check if it is independent. How about mutually exclusive? Mutually exclusive meaning that PA intersect B is equal to 0. Okay, if you want to see from Venn diagram, A and B cannot be intersect. It's like that. Okay, so from this formula here, therefore you can also check another one. PA union B is just PA plus PB. Why? Because the intersection back here is equal to 0. Okay, I hope you are clear with this two notation here. This two notation here is very crucial for this chapter. Okay, so now how to check it is independent? You see, we already have this PA intersect B. Okay, so let's check. Okay, I use this blue pen here. Okay, let's check using this formula. If it is independent, these two must be equal. So we already have this answer here. So this is 0.02. And let's check this one. What is PA? 0.6 times PB, 0.1. Okay, what is 0.6 times 0.1? Is it this? Do you get the same? This is 0.06. So now, is it equal to each other? These two numbers here?
No.
No, okay. So please do this separately. PA intersect B is equal to this. PA times PB is equal to this. So since these two are not equal to each other, therefore it is not independent. Okay. I hope this is clear. Next one, is it mutually exclusive? Let's check. Is it mutually exclusive? All right. If it is mutually exclusive, intersection should be equal to 0. But now, what is our intersection? Now, intersection, do we have value for it? Yes, 0.02. It's not equal to 0. Therefore, it is not mutually exclusive. Okay. Is this clear? I'll give the PDF later to you. Right? Okay, can we proceed?
Yes, madam.
Okay, so next one, the probability of event is given as below. So you have all of this information here. You have A, B, C, and this is crucial. B and C are mutually exclusive. Okay, so if you want to graph the Venn diagram here, you need to do something like this. Wait, you need to draw it is like this. Okay, because B and C are mutually exclusive. So B and C will not have intersection, but AB and AC you have intersection. Okay, so let's fill in what we know from here. The whole PA is 0.4. The whole PB is 0.37. A and B union. Okay, A and B union. Let's write here first. A and B union is 0.55. Okay, A union B is 0.55. A intersects C. A and C. Okay, A and C. This is 0.1. And then the whole C is 0.31. If the whole C is 0.31, what is this area here? If the whole C is 0.31, what is this area here? Zero 0.31. The whole thing is 0.31 minus. How should you do this? The intersection here is 0.1. The whole thing is 0.31. So what is this area here?
0.21.
0.31 minus 0.1. So this is 0.21. Okay, so you have that area here, that area there. The first question asks you, what is PA intersect B? So just use the formula of, wait. Let me write the first formula here. So just use this formula, PA plus PB, okay? PA union B is PA plus PB minus PA intersect B. Okay, and then we want this part here. So just rearrange it, okay? Put it in the front. And then it's just PA plus PB minus the minus PA union B. So just fill in, then you should get your answer. The second question asks you for PA union B, PA union C. So just open up formula, PA plus PC minus PA intersect C. You have PA, you also have PC, you also have PA intersect C. So just fill in everything. Right? And lastly, just use calculator, you should get the answer. Right, so let's look at part C. Let's look at part C union B. Okay, so it's mentioned here P and C are mutually exclusive, and then it cannot have intersection. Therefore, the formula is just PC union B is just PC plus PB. So just take your answer for PC. Just take the value of PC and put here the value of PB. So get your answer here. And next one, PA complement. All right. So let's just use complementary rules. It's just 1 minus PA. Okay, so your PA is 0.4. Just fill in 0.4. So 1 minus 0.4 is 0.6. Okay, next one for D. For E, PB complement intersect C. Okay, B complement intersect C. So let's see here. This whole thing is your B. And outside of the ring of B here is B complement. Okay, outside of this ring here is B complement. And you want to intersect it with C right now. So the answer is the whole C. Okay, just take the whole C, which is PC just now is 0.31. And lastly, intersection of A complement and B. Okay, intersection of A complement. So this is A. Outside of A is A complement. And then you want to intersect with B. So how should you do this? We have the value of this intersection, right? We already have the value of this intersection here. Intersection of A and B right now is 0.22. Okay. So how to find A complement? I think you have two ways to solve. 0.37. Okay, I think you can see this clearly here. Right, so this is your A, this is your B. We already have the intersection here, 0.22. Okay, and the whole thing of this PB here is 0.37. Right, so we can find intersection of A complement. Okay, this A complement, this is A, other than A is A complement, and you just want to intersect with B. Okay, so you want this part here. Okay. So just take the whole value here, PB. Just take the whole value of PB, and you can just minus PA intersect B. Right, so 0.37, the whole PB, minus intersection 0.22. So the answer here will be 0.15. Right? Any question? Any question?
No, madam.
No, eh?
No, madam.
All right, so that is 5.3. Let's go on to 5.4. Okay, this is from Siti Safia. This is conditional probability. So let me revise with you. PA intersect B is just PA union B over PB. Okay, this is formula for conditional probability. Okay, so this is given as you have PA is 0.5, you have PB given A is 0.45, and PA complement intersect B is 0.25. So the question asks you for A intersect B. Okay, so since you have conditional here, you know that A is happening first. Okay, if you want to draw a tree diagram, A is happening first, this is A complement, and then B is happen next one. So this is B complement, this is B complement. Okay. So this branch here is probability of B given A. Second branch is B complement given A. B given A complement. This is P. B complement given A complement. Okay, this is the way to write a tree diagram. So the question asks you for A intersect B. Okay, A and B. So for A and B, just find the branches for this A and B here. Let me write here. This is PA. This is PA. Right. So if you want PA and B, just find the branches for A and find the branches for B, and then you just multiply them. Okay. Just multiply the value. So just take PB in given B, PB given A, just multiply with PA. Okay, so you can get here 0.45 times 0.5, it is 0.225. Next one is PB. Okay, that's what is PB. This is law of total probability. Okay, so because your B is not stands alone, B is depending on the previous event. So law of total probability is just multiply this branch here. Another B is here, so multiply also this branch here. Okay, and add them up. Okay, I hope you remember this. I hope you can understand this from the video I've shown you. Okay, law of total probability. If you don't want to write the formula, just draw this tree diagram and then look at the combination of B and the event before it. Multiply and then add them up. Okay, for C, A union B, so just open up the formula. Okay, just use the normal formula. PA plus PB minus intersection. Okay, we already have the answer for intersection, so just fill in PA from the question. Okay, PB from part B. Right, and then next one, PA given B. Okay, do you have this in the tree diagram? Do you have PA given B from the tree diagram?
No, madam.
No, eh? Since you don't have it from the tree diagram, because for the tree diagram, we only have PB given A. We don't have PA given B. So just open the formula. Okay, open with the general formula as what I've shown before. So it's just PA union B divided by PB. Here we already have the answer for PB intersect. Sorry, the formula is PB intersect A over PB. Okay, we already have the answer for this one because this is just the same with A intersect B. Okay, we have this answer from part A. Okay, so just take the answer. And then we already have PB also from part B. Okay, just multiply. No need to use this other formula. This is just from part A, this is just answer from part B. Just take the answer. Okay, 0.225. So just divide it, you'll get the answer. Okay, next one. Question asks you for A intersect B prime. Okay, A intersect. If you are A and B complement, just find where is A, where is B complement. So this is this part. Okay, from your tree diagram, this is A, this is B complement. Okay, so just take the value of these two branch here, just multiply the two branch here. Okay, multiply them, you should get the answer. Okay, so maybe this is another alternative, but I'll show you the way to use the tree diagram. So just multiply B complement given A, and you just multiply with P, A. Okay, so just take the value and then just multiply them. Or you can use other ways. Okay, this is another way. I think this is from tree diagram. Okay, I think Safia got this from the tree diagram. From the Venn diagram, sorry. You may use the Venn diagram because you know it is not mutually exclusive. Okay, this is A, this is B. You already have the value for the whole PA from the question. You have the value from the whole PB from part B. You have A intersect B from part A. Okay, so I think Safia did this, the formula here from the Venn diagram here. Okay, so A intersect B complement, this is B. Other than B is B complement, and then intersect it with A. So this part here. So Safia take the whole PA, 0.5, and then she minus the intersection, 0.225. Okay, so you can do both ways, doesn't matter. I think in this case, Venn diagram is a bit simple, right? And the final question, are events A and B independent? Okay, so we cannot do it manually. Cannot just look at it by your own eyes. You need to test it. Okay, so I think we can straight away look at it. Because we have this condition if it is independent, right? Okay, we have this condition here. PA intersect B, PA given B, PA given B is equal to PA, okay? So if it is independent, you should get this value here, okay? But our PA given B just now from the question is 0.474. Our PA is now 0.5. So since PA in given B is not the same with PA, therefore it is not independent. Okay? If they ask for mutually exclusive, the answer is also no. Not mutually exclusive because we have the value of intersection just now 0.225. Okay, it's not equal to 0. Right? So let's see the next question here, 24. Oh, it's past 9 a.m. now. Do you have class? Do you have class at 9? I try to take, I think another 10 minutes. Is it okay?
Yes, ma'am.
Okay. Okay, we are finishing it. Next one, a factory uses 2 machines. Okay, so you have A and B. Okay, producing wafers. Suppose machine A produce 70% of wafers. Okay, so you have A and B. So now from the question, PA is 0.7. Okay, then let's read further. 5% are defective. Okay, so from machine A, 5% are defective, meaning that there is probability of defective given it is from machine A. It is 0.05. Okay, that is the way to look at the question. So given A as machine A, B, make it as machine B, right? And then given, and then let's take D as defective and ND as not defective. Okay, so from the question, we already got PA and we already got PD given A. Let's read further. PD produces 30%. Okay, so PB is 0.3. Okay, and another one. From machine B, 6% are defective. Okay, so given that we are using B, it is defective. Okay, as much as 0.06. So we can draw the tree diagram here, starting with PA. So starting with PA and PB. And then the next one is defective, not defective. And from B, defective, not defective. Okay, so this branch here is D given A. This branch here is ND given A. D given B. And D given B. Right? So I hope you're clear. Even though we only have 0.05, we can find another value here using complementary rules, 1 minus 0.05. Even though this is just given 0.06, you can just take 1 minus it, so 0.94. Let's see the first question. Question said, find the probability that produced by machine A and not defective. Okay, so A and not defective, this is the notation here, intersection. So let's do the simple way. How to do it? How to find it is you just find which one is connecting ND and A. Okay, so since you want both of them and, meaning that just multiply its just multiply its branches here. So just take 0.7 times 0.95. Okay, so just multiply the branch here. Next one, find the probability of given produced by machine B. Okay, defective given produced by machine B. Okay, so it's D given B. Okay, I don't know why they asked this question because it's straightforward. No need to calculate. Straightforward. PD given A is just 0. Sorry, PD given B is straight away 0.06. Okay, if you don't want to calculate, it's also okay. Okay, but let me just show you. If they ask you the other way around, PB given D. So in this case, let's save this first. Let's do it later. Let's do question C first. Find the probability that it is defective. So now we are looking at PD. Okay, defective PD. So this is law of total probability. So let me use the pink highlighter here. Okay, so defective. Defective is the first part and the second part. Okay, so just use law of total probability. This part here, multiply with this part here. Okay, after this part here, multiply, add with this part here. So you'll find the answer 0.053. And lastly, they ask you for P not defective. Okay, so P not defective, this is not defective, this is not defective. So you need to multiply this at the branches plus multiply this at the branches. Okay, I suppose they ask you for PB given D. Okay, they put the other way around. So we can just open up the formula, multiply PD. Okay, so just use the formula. So PB intersect D, the intersection. B intersect D, okay? So let's see here. B intersect D. So this branch here, so just put it 0.3 times 0.06 over PD. So we already got the answer for PD, 0.053. Okay, so you can just use calculator. The answer now is 0.000954. Okay, that's the way to do it. And finally, let's see the last one. Okay, this is the same question. Sorry, I didn't notice. I gave you the same question. Okay, so no need to repeat when you do tutorial. Okay, I think question 7 you can look on your own. Okay, because this is very straightforward. Let us discuss this one. Okay, the last example here. A market survey of a branded shampoo shows that 62% of the female respondents are satisfied with the product, and 3% of the male respondents are not satisfied. Okay, so this is probability of female respondents satisfied. So satisfied, given that the respondent is female, is 0.62. And this shows us this is probability of not satisfied, given that it is male. Okay, so let's use M for male, F for female, S for satisfied, and S for not satisfied. Right? So, and S given M, okay, 0.03. And it's found out also 36 of the respondent here are male. Okay, so another one that given here is female is 0.36. All right, so just write everything that we have here. This is the first event, female and male. Okay, so let's put in the male first, 0.36. So 1 minus it is 0.64. And then the second event, either they are satisfied or not satisfied. So just fill in the first thing that you have here. Okay, the first thing that you have here, S given F. S given F here is 0.62. So this is the complement. And then S given M is 0.03. This is the complement. Okay, the first question, Not satisfied, find the probability of not satisfied. So this is law of total probability. Okay, so not satisfied is here, depending on these two conditions here. So just multiply this plus just multiply this. Okay, law of total probability. Then you'll get the answer. B is a male who is satisfied. So this is intersection because this is already at the same time. Male who is satisfied. Okay, so MS. So let's find M. Okay, use the orange color. Let's find M, this part here, and find S. So this part here. Okay, so just multiply them. All right, so you'll get the answer. Next is a female. All right, so is a female. Female is here, MF. Okay, sorry, PF, probability of female. So this is just 1 minus 0.36, so 0.64. Next, not satisfied given that if it is known that it is a male. Okay, so not satisfied, not satisfied. Green here, okay, not satisfied given that it is a male. Okay, not satisfied given a male. I think this is straightforward. I don't know where they ask it, why they ask. This is very straightforward. This is not satisfied given male. Satisfied given male. This is the branch 4. Not satisfied given female. Satisfied given female. Okay, and S given M. This is just straightforward, 0.03. Okay, so straightforward as 0.03. Okay, not satisfied with product if it is known it is female. Okay, not satisfied with the product given that it is a female. This is also straightforward. I don't know why they ask you again. And S given F. This is it. Very straightforward, 0.38. Unless they want to flip it. Okay, let me show you how to flip it. Okay, for example, the question asks you this. F given NS, okay? So this is not in the table, it is not in the tree diagram because we have flipped it around. Okay, so this one you can just open up the formula. F given NS given probability of NS. Okay, F given NS, okay, we don't have F given NS, so let's look. Let's find it by ourselves. This is F and NS, okay, intersection. Okay, intersection, so both of them. So just write 0.64 times 0.64 times 0.64 times 0.38. Okay, divide by NS. We already find probability of NS using the law of total probability for part A. So just fill in 0.254. Okay, I hope you can follow the way to calculate this. So let's use calculator. The answer is 0.957. Right. So let's see the last one here. F is a female or satisfied. Okay, so this is or, so using union symbol. So just open up the formula. Okay, this is not using tree diagram, this is just using the formula. PF plus PS minus PF intersect S. So we have PF. We have PF here, so put it in. We have PS, okay, so you can find PS from the tree diagram or you can just use the complementary of 1 minus P not satisfied. Okay, so we already have P not satisfied 0.254 from part A. Okay, so you can just minus it. Okay, so you get PS. Okay, another way is you just find from the tree diagram. Okay, just multiply and plus. And minus the intersection of F and S. Okay, intersection of F and S. This is the intersection. It's written here from the tree diagram, right? F and S, this part here. Okay, 0.64 minus times 0.62. So after you do this, you can get the answer.
Okay, let's go to last example here. Siti goes to school in the morning by taking either bus A or bus B. The probability that she will take bus A is 1 over 3. So let's write here PA is equal to 1 over 3. The probability that she is late when taking bus A is 1 over 5. So this is probability of late given she is taking bus A. This is 1 over 5. So A is taking bus A, B is taking bus B, L is for late, and then E is for early. Let's write the notation there. And let's proceed. The probability that she is late when taking bus B is 1 over 6. So probability that she is late when taking bus B is 1 over 6. So the question said, find the probability that Siti is late on Monday. Okay, so we want the probability that she is late on a certain day on Monday. So let's draw this tree diagram first. So the probability of A and B is here. So taking bus A is 1 over 3. Therefore, probability of taking bus B is 1 minus 1 over 3. Use the complementary rules. And then late when taking bus A, this is 1 over 5. So this is complementary, 4 over 5. 1 minus 1 over 5 is 4 over 5. Probability when it's late taking bus B is 1 over 6. So the complementary is 1 minus 1 over 6. So it is 5 over 6. Since the probability of late is at two places here, depending on A and B, this is law of total probability. So just multiply the two branches here and add them up. So you'll find the answer 8 over 45. The second question asks us, if given she is late, what is the probability that she will be taking bus B? So this is probability of getting on bus B given late. Okay, so you don't have it in your tree diagram because in tree diagram here is late given A, this is early given A. This is probability of late given B. This is probability of early given B. So you don't have probability of getting on bus B given late. So this is the opposite of this one. All right. We don't have any other options. The only options is to open up the formula using conditional probability. So this is P B intersect L over probability L. So probability B intersect L, BL is here. So since it's intersection, okay, so we need to multiply this branch here. So it is 2 over 3 times 1 over 6 over probability of late. So we already found the probability of late in part A here. So just fill in this probability of B intersect L, which is this part here, 2 over 3 times 1 over 6, and divide with PL, which we already have the answer here, 8 over 45. So just use a calculator, your answer is 5 over 8.